So here is what we call weak induction. We'll get to strong induction tomorrow. So weak induction, you'll see the difference tomorrow. So weak induction goes like this. So to prove this claim, and the claim would be something like, for all in the set like this, P of n. So this set right here, this set is the set of all, actually I could even use, I should probably even use z here to be the integers. So this saying that for all n integers greater than or equal to a. The point being, like the domino thing, I started at the first domino, but there's no reason I didn't start at the fifth domino, right? Or something like that. Or if there's a 0th domino, I could have started there. The point is there's integers starting at a certain point. So if a was, so for example, if you have x and z such that x is greater than or equal to 5, well, this just represents the set of 5, 6, 7, 8, 9, 10. Oh, no, you start counting at 10. Or sorry, counting at 5. So that makes sense. You guys are smart. So the point is, for all n in this set, P of n is true. To prove a claim like this, to prove by weak induction, here's what we do. We say proof. We always say proof. Don't forget that, people. People are forgetting that these days. Always say proof. And always write down your statement formally. This is the formal claim. The informal claim is that for all integer n greater than or equal to a, P of n is true. So that would be like the informal. This is the formal. But the proof goes like this. You always say proof by weak induction on n. I'll write that lower. I don't like where I put that. Proof by weak induction on n. And so this tells you we're going to be using weak induction. And the on n, that tells you that's kind of like the variable it's going to be used in your chain. You'll see what I'm talking about in a second. And so we always start with a base case. And the base case is just connecting the chain to the truth. That's like saying the first domino will fall. That's what the base case is. It starts off the chain reaction. So the base case, what you do is you let n equal a, and then you prove P of n, which is equivalent to P of a. So P of n, remember, this is a predicate. It represents a statement, right? Or a statement once you plug in a variable. And so here, what we're doing here is this is here, prove P of a is true. Just like saying first domino falls. And then next you have the inductive step. So the base case kind of sets everything off. But now we need the inductive step to prove the chain reaction works if we wanted to. And so the inductive step goes like this. It says, for all n, or want to prove, need to show that for all n greater than or equal to a, so for all integers n greater than or equal to a, P of n implies P of n plus 1. This proves all the lengths and our logic chain hold. And so what I mean by that is if we're looking at that kind of logic chain thing again, where it's like P of A, that's connected to the truth by base case. Base case is P of A is true. This is truth right there. And then from there, our inductive step, well, this gets us to P of A plus 1. It gets us to P of A plus 2. It gets us to P of A plus 3. It gets us to P of A plus 4. And eventually gets us to every integer bigger than A, bigger than or equal to A. So this is by base case. And this is by our inductive step, inductive step, inductive step, inductive step, inductive step. So this is the logic chain right here. The base case starts it off, and the chain reaction takes over and says, oh, it's going to work for everything after that. And then we have a conclusion. Based on this picture right here, we can see that, therefore, P of n is true for all integer n greater than or equal to A. So just to make it real clear, here's where your proof is. And this is weak induction. We're gonna do, if I had my way, 1,000 examples of this, but time permitting, probably like 4. But we're gonna do more on Wednesday and Friday. But yeah, this is the idea of mathematical induction. And I hope it makes sense. Or I hope this picture makes sense. All we're saying is that if you prove P of A is true, and then if you can prove that P of A implies P of A plus 1, P of A plus 1 implies P of A plus 2, P of A plus 2 implies P of A plus 3, you have this chain reaction here. Oh, well, then it's got to be true for all n greater than or equal to A. Does that make sense? It's just dominoes. Going once? Going twice? Good. Then sold to everybody, because math belongs to all of us. It's actually an interesting legal discussion if you can copyright math or not. But but I don't believe you can. So anyway, that is our process of induction. Let's do some examples.